Alright guys, welcome to day 3 of the notes in this unit. We saved the best for last. Today we're going to talk about dilations with slope. Okay, so we're going to start by making sure you remember what slope is from Algebra 1. So the first thing I want you to add is just remember that slope, sometimes we use m to represent slope, is rise over run. Okay, that's probably the most common way you heard it, or you might remember it's the change in y over the change in x, which y is your vertical, so that's your rise. X is your horizontal movement, that's the run. So if we're using the graph below to find the following slopes, to find the slope of line A, I just look at line A, and you can choose any 2 points on line A. I'm just going to use the 2 that are already marked for us. And I'm going to count how much I rise over how much I run to get from one point to the other. So from this point to get to this point, I would have to rise 1, 2, 3. So my rise is 3, and my run is 2. So I would have to go up 3 and to the right 2. Alright, up is a positive direction, and to the right is a positive direction, so both of those are positive. So my slope is positive 3/2. Okay, so same deal for the line, or the slope of line B. I'm going to use the 2 points on line B that are marked for me. And from 1, I'm going to count how much I rise. So I rise 1. And then I run to the left 3. Alright, to the left is a negative direction. So 1 positive, 1 negative makes this become a negative slope. Alright, or you can look at the lines. If the line as you go from left to right is increasing, then it's going to be a positive slope. Line B as I go from left to right is decreasing, so it's going to be a negative slope. So just be careful, make sure you put the right sign. Okay, next we have slope of line C, which if I use the 2 points on line C, I would rise 2, but I would run 0. If you haven't ever heard it, you cannot divide by 0. 2 divided by 0 does not exist. So this is undefined. There is no slope. Alright, so straight vertical lines, just straight up and down, are always going to have an undefined slope. And then lastly, if you got a straight horizontal line like line D, still if I'm talking about rise over run, now I'm not rising any, but I'm running to the right 3. Well, 0 divided by 3 is 0. So my slope would be 0. So just to review, if we're given a graph of a line, we can just choose 2 points and then count the rise over the run to get from one point to the other, and that's our slope. Okay? Now sometimes they don't give us a graph. Sometimes maybe they just give us 2 points or information about the line. And so another way we can find slope is using the slope formula. So when given the coordinates of 2 points, the slope can be found using this formula. So like I said earlier, this is your change in y over your change in x. Alright, we're finding the difference between the two y values. So we do y2 minus y1 divided by the difference between the two x values, x2 minus x1. Okay, so for an example, they asked me to find the slope of line segment AB with A at -2, -6, and B at 1, 2. Okay, so before I start, if you're really good with the graph, you could always sketch a graph and do it just the way that I did up there in the previous examples. Or you could use the formula. So to use the formula, we label our points, call the first one x1, y1, and call the second one x2, y2. And then we use the formula for slope, y2 minus y1 divided by x2 minus x1. And we plug in our values. So y2 would be 2 minus y1, which is -6. So yeah, put minus -6. I'll talk about what to do with that in a minute. Then in the bottom is x2, which is 1, minus x1, which is -2. Then we simplify the numerator and denominator. So 2 minus -6, when you subtract the negative, we add. Same thing in the bottom. 1 minus -2 will be 1 plus 2. Then in the top, 2 plus 6 is 8. In the bottom, 1 plus 2 is 3. So my slope of that line would be 8 over 3. So if I were to draw the points and count how much I rise over how much I run, I would rise 8, run 3. Same idea. Okay, so now what I want you to do is pause the video and try and do example 3 on your own. Okay, so see if you can use the formula. Label your points x1, y1. Label your other point x2, y2. Start by writing down the formula, plug in your values, and simplify. And then you'll restart the video and we'll talk about it. Alright, welcome back. So if you did that problem correctly, in the numerator you should have gotten negative 6 over 4. Alright, so always be sure you reduce that fraction. They have a common factor of 2, so I reduce it by 2, and your slope on that problem would be negative 3/2. Alright, so things to check: make sure you reduce your fractions when possible, and also make sure that that slope turned out to be negative 3/2. So now that we know and remember our information about slope, it can be useful in dilating images. So now I'm going to talk about how to dilate an image, what that means, and how to use slope to help you. So in example 4, we have a triangle ABC. We're going to use slope to produce a dilation of triangle ABC with a scale factor of 2. Alright? Scale factor 2 means we're going to multiply and make it 2 times bigger. Alright? We're going to use the origin, 0, 0, as our center. Alright? So wherever your center is, go ahead and mark it. Ours is at 0, 0. And we're going to analyze each point, A, B, and C. Now, B got left off, so if you would add a space for B, we're going to do B also. I'm going to analyze the slope from 0, 0, our center, to each one of these points. Okay? To help us, as we go through, I'm going to write down the original coordinates. Alright, so the original A over here would be at negative 2, 3. The original C is at 4, 2. And then the pre-image of B is at 1, 2, 3, 2, 3, 4, 3, 5. Okay, so whenever we dilate this by a scale factor of 2, we will have our image points A, B, and C, and those will be our new points. Alright, so I use slope. Like I said, from the origin, we'll start with A. I count the slope to get from the origin to point A. So I'm going to call it M sub A for the slope of A. So my slope here would be, I would rise 3 and run to the left 2. So my slope is negative 3/2. Since it's going up and to the left, it would be a negative slope. Okay? Well, to dilate this by a scale factor of 2, I just multiply both the top and the bottom by 2. And those numbers become 2 times bigger. So in the top, I'm going to get 6. In the bottom, I get 4. Okay? So now that's my new slope to get to A prime. So I go up 6 and to the left 4. So my coordinates here are at negative 4, 6 of my new point, the image of A. So next, just to go alphabetical, I'm going to do B next, even though it got left off. B is at 3, 5. So I count the slope from the center. I would go up 5 over 3. So my slope of B would be 5 over 3. And since I'm going by a scale factor of 2, I multiply those by 2, and I get 10 over 6. So my new point from the center should be up 10, 1, 2, 3, 4, and to the right 6. Alright, so right there would be B prime, and the coordinates of that would be 6, 10. I wrote that in the C spot, so change that to the B spot. Alright, so now we're going to go do C. So the slope of C, same idea. I would rise 2, run 4, so the slope is 2/4. I'm multiplying by a scale factor of 2, so I would get 4/8. So to get to C prime, I go up 4 from the center over 8. So the coordinates of C, now be sure you put it in the C spot, I messed that up, would be at 8, 4. Okay, and if you want to see it, I use my ID as my straight edge, and then I'll connect these lines so that you can kind of see the new triangle that's produced that is dilated by a scale factor of 2. So you'll notice it looks 2 times bigger. Okay, also something that if you compare, the reason I wrote these down is I wanted you to see when we multiply by a scale factor of 2, there's a pattern here. Each coordinate is just getting multiplied by that scale factor of 2 to give me my new coordinates. Alright, now this is only when the center is at 0, 0, which is what we're talking about right now. But if the center is at 0, 0, then you just multiply those values by 2 by whatever your scale factor is, and you get your new points. You plot them and graph them. Okay? So, if you need to, pause the video, rewind, watch that again. But we're going to move on to example 5. So example 5, use slope to produce a dilation of triangle XYZ with a scale factor of 1/2. So now it's getting multiplied by a half. It's becoming half the size it used to be. So we're still using the origin 0, 0 as your center. And again, they gave us y and z, add x here. We're going to do all 3 points, the whole triangle. Alright, and I'm going to start, same deal so that we can analyze. I'm going to put y, z, x. I'm going to put the original coordinates over here, just so we kind of see that pattern. So y is at -4, -4. Z is at 6, 0. And x is at 2, 8. So we can use our idea of slope, and I just like to go alphabetical, so I'm going to do x first. My slope from the center to x would be a rise of 8 and a run of 2. Well, now my scale factor that I'm multiplying those by is a half on top and bottom. 8 times 1/2 is 4, and half of 2 is 1. So the new point would be up 4 over 1, which would make its coordinates 1, 4. So just point out the pattern again. Notice I could simply just multiply those by half. That's what's happening. Alright, so when I do y, the slope of y, we're going to go rise 1, 2, 3, 4, down 4, left 4. So -4 over -4. Those are getting multiplied by half, which makes it -2 over -2. So I go down 2, left 2. Those are both negative directions. There will be my new y. So its coordinates are -2, -2. So again, notice the coordinates just got multiplied by half. When your center is at 0, 0, you can do that. Then my slope of z would be rise 0, run 6. So it has a slope of 0. When I multiply that by half, 0 times anything is 0. 6 times a half is 3. So it would be up 0 over 3 would be the new z. So its coordinates would be 3, 0. Same pattern. Notice both the x and y value just got multiplied by half. So then you can connect your lines to see the triangle. Spaghetti sauce, spaghetti sauce. And there you go. You got this new triangle, which is a dilation by a scale factor of 1/2 of the original. Thank you very much. You are welcome.